Properties of rhombuses, rectangles, and squares. So we want to be able to use the properties of a rectangle to determine angle measures and side lengths. We want to do the same thing with a rhombus, and we want to do the same thing with a square. And then if we're given a parallelogram on a coordinate plane, we need to be able to show if it is a rectangle, a rhombus, or a square. So a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And a square is a combination of a rhombus and a rectangle. It has 4 congruent sides and 4 right angles. So a square is a regular quadrilateral because it is equiangular and equilateral. So our corollaries about rhombuses, rectangles, and squares pretty much say just that. That a rhombus is only a quadrilateral is only a rhombus if and only if it has the 4 congruent sides. So if AB, BC, CD, and AD are all congruent, then your quadrilateral is a rhombus. Your quadrilateral can only be a rectangle if and only if it has 4 right angles. So if A, B, and C, and D are all right angles, then your quadrilateral is a rectangle. And then lastly, a quadrilateral is a square if and only if it is both a rhombus and a rectangle, meaning all of the sides are congruent, like a rhombus, and all of the angles are right, like a rectangle. So let's look at example 1. For any rhombus, we need to decide if this statement is always, sometimes, or never true, and then we need to draw a sketch and explain our reasoning. So I've got ABC is greater than BC. So first I want to draw my rhombus, and then I'm going to label my vertices. And remember, when you're naming a parallelogram, they go in, the vertices go in order. So A, B, C, D, A, B, C, D. And then the question is AB greater than BC? Well, if we have a rhombus, then by definition, all of my sides must be congruent. So therefore, this would be never. AB is never going to be larger than BC. All right. This rhombus, I've got A, B, C, D, and I want to know about measure of angle A. Is it ever bigger than the measure of angle B? Well, by definition, these two angles must be supplementary. That's the definition of parallelogram. Consecutive angles supplementary. Now, if they're both 90, then that would be a square, but that is possible because that's technically still a rhombus. So this would be a sometimes, but they are not. A is not always bigger than B. B could sometimes be bigger than A. So this would be a sometimes. And in this instance, A does appear to be bigger than B, but the only stipulation is that they are supplementary. All right, so we want to classify the special quadrilateral, and we want to explain our reasoning. So, I know that these two lines are parallel. Both pairs of opposite sides are parallel. So I do have a parallelogram. This side length is longer than this side length, so it cannot be a rhombus. It could also not be a square, so my only option is rectangle. All right. Next, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So AC and BD are perpendicular to each other. A parallelogram is a rhombus if and only if the diagonals bisect opposite angles. So as you can see, AC is an angle bisector of both angle A and angle C, and BD bisects angles D and B. And then last, with my rectangles, a parallelogram is a rectangle if and only if its diagonals are congruent. So that means that AC is equal to BD. But remember that a parallelogram, your diagonals bisect each other. So if AC is congruent to BD, then that means the pieces that are bisected must also be congruent. So I want to sketch rhombus ABCD, and I want to list everything I know about it. And by listing it, I'm going to draw it. So here's my rhombus, A, B, C, and D. And because it's first a parallelogram, I know that opposite sides are parallel. Okay? I also know, because it's a rhombus, that all four sides are congruent. That's what I know about my sides. Let's talk about diagonals. So this is my diagonal BD, and this is my diagonal AC. And BD cuts this angle in half. But remember that angles B and D are congruent, so all four of these little angles are congruent. Angles A and C are also congruent, and they are bisected by diagonal AC. Other things I know about my diagonals: I know that they are perpendicular, and because a rhombus is a parallelogram, I know that my diagonals bisect each other. So this portion and this portion are congruent, and this portion and this portion are congruent. Alright, so take a look at these practice problems, and we'll get back together tomorrow and talk more about special quadrilaterals. Alright, so make sure that you have your sketches here, but number 1 is always, number 2 is sometimes, number 3 is always, number 4 could be a rhombus and a rectangle, so then your best answer would be square. Number 5, your best answer is a rhombus. And then number 6, I didn't list everything, I drew it on here. Opposite sides parallel, all four sides congruent, diagonals are congruent and bisect each other and are perpendicular. Diagonals also bisect the angles, which are all congruent because they're all right angles.